Everybody stop.
Water doesn't mean it's not wet.
As a science teacher, I feel obligated to talk about this simply because I need you to stop talking about it. My brain's every night I cry a little bit when everybody comes up to me. So let's talk about this logically, okay? We are going to logically solve this problem. We are going to use our collective brain power to solve it. Here we go. I promise you can. What is? So
you can't
this
swim.
Is. Are you videotaping this?
Yes.
Okay, I'm okay with that. This is what we call a definition problem. The problem is you have to first define the terms before you can solve the problem.
Okay.
So let's just define the terms. What does the term wet mean?
It means it's wet.
Well, yeah, but what does it mean?
Covered or saturated with water or another liquid.
Okay, great. To be covered in liquid, right? Everybody okay with that?
Mm-hmm.
All right, so let's think about this chemistry-wise. A single solitary molecule of water. If you are one molecule of water floating around, you are not surrounded by water, correct?
Mm-hmm.
Yeah.
So would you be wet?
No.
No.
Correct. Now, pause. But if you are a drop of water, you are a billion molecules all swimming around each other. So therefore, all the molecules in a drop of water would be surrounded by water.
So it's
True.
So therefore, in a drop of water, all of the molecules, by our definition, would be wet.
Suck it.
What's that?
They are the water. They're not surrounded by.
But they're still surrounded by it, right? I'm a person, but I can still be surrounded by people.
When you pour water,
Okay.
more water.
So the other thing is,
Moving on.
pause. The other thing is this, though: a single solitary molecule of water is not in a liquid state either; it would be a vapor. And so in this case, so vapor wouldn't count anyways. So yes. Like okay, so like ice, right? If I wrapped you in ice, you wouldn't be wet. You would just be cold or dead, right? You're not. So it has to be liquid water. So if it's a single solitary molecule floating around, it wouldn't be in the form of a liquid water. It'd be a vapor. So yeah, that's the science logical explanation of it.
So
I believe
boom,
water is wet.
water's
Mr.
wet.
Thompson said that it wasn't wet. He might be.
Mr. Thompson is insane.
Mr. Thompson is wrong.
So are you.
I am logical.
I will still argue.
Don't tell Mr. Thompson that. I know you're recording this, which is funny. So hey, pause. By our definition,
Water is not wet.
water would have to be wet. Now, if you want to change the definition of wet, then it's different. It's the same deal as this. Have you guys heard the problem where like people say, if a tree falls in the forest and no one is around to make it, doesn't make a sound? Have you heard that?
Yeah.
Well, that depends on how you define sound.
Is fire burnt?
If sound is just the compression wave made by the tree falling, then yes, it makes a sound.
Is
But
fire
if
burnt?
sound, pause, if sound is our ears detecting the compression wave and turning it into a sound in our brain, then no, it's not. So it's a definition problem. Okay, bring it back together, team. Okay, now you can stop recording. That's